here at SMU, and I would like to welcome you to our presentation about mathematical problem solving in real-world situations. This presentation will discuss connecting mathematics concepts in upper grades to real-world contexts and students' interests and experiences. As a teacher, I think this is important because we have to find ways to engage our students in their learning. And if students see a connection between mathematics topics and the real world, their interest in mathematics will increase. So our speaker today, Dr. Candace Walkington, is an assistant professor in teaching and learning here at Southern Methodist University, and she specializes in mathematics education. She holds a Bachelor of Science and a Master of Science from Texas A&M University and earned her PhD in mathematics education from the University of Texas. She conducts research on personalizing mathematics instruction to students' out-of-school interests like sports, music, shopping, and video games. She also examines ways to connect mathematical practices with physical motion. Dr. Walkington has worked with the UTeach Secondary Mathematics and Science Teacher Preparation Program at the University of Texas at Austin, as well as the Gates Foundation's Measures of Effective Teaching project and the Next Generation Learning Initiative. She teaches courses for pre-service and in-service mathematics teachers at SMU, and acts as the chair of the STEM Program Committee in the School of Education. Please join me in welcoming Dr. Candace Walkington.
All right, thank you guys. So today we're going to be kind of zeroing in on one really important TEKS process standard that we heard about this morning. And this is the one where students will apply mathematics to problems arising in everyday life, society, and the workplace. So I'd like to say, beginning of this presentation, maybe it's controversial, is that there's ways to do this well, and there's ways to do it not so well. So I want you to turn to somebody who's sitting next to you, kind of discuss what does this mean and what is not intended, what does not fall under, what kinds of tasks might not capture what this process standard really means.
Needing students to think about.
All right, so who can give me a non-example, a counter-example of how we shouldn't interpret this process standard?
Passing out a worksheet with two-step equations on it.
Passing out a worksheet with two-step equations that doesn't have any story around it at all. All right, what else? What did you guys think?
Even these worksheets with story problems on them, right? A lot of them are extremely artificial, right? The video we watched, like one of my partners said, the video we watched in the beginning, right? The kid's like, oh yeah, you're a quarterback, you have to calculate the throw. No, you don't, right? Your arm does that, right? You have to train it how to do it. You don't have to have any mathematical knowledge to throw a football well.
Right, so you don't need that mathematical knowledge to throw a football well, but it's really interesting. Here in the Simmons School, we have people who calculate people's throw and people's kick in order to help them with physical therapy and to improve their sports performance. So there is an application for it, but when you're actually in the moment, it's not a useful application.
Well, we were discussing that in a real world problem situation, this situation comes before the math. So that you think of, like we're talking about a rocket launch. We don't say what quadratic parts of this is the rocket launch. We say, here's a rocket launch, what math does it represent? So it's kind of the opposite of what we tend to do, which is, I'm thinking about a quadratics problem, I want to make a real world problem to fit it, we have to go the other way. So real world is, what are we doing first before what math applies?
And if you start with the math in the way that you're describing, you end up with something very artificial when you try to make it into a story problem. And a point that I also heard brought up over here is that how is this really being assessed on our standardized tests? Are these good real-world problems? Or are they artificial ones that are just kind of an excuse to teach some abstract equation? Okay, so I always like starting out sessions by getting you guys to do some math. So I want you to try to tackle this problem. You're definitely probably going to need to work with a couple other people. This is a really famous real-world problem in high school geometry. It's a great problem, and because this actually mirrors a true story, The mathematician and astronomer Aristophanes read that in the city of Syene, at noon on June 21st, a vertical meter stick cast no shadow. However, he observed that on the same day and time, in the city of Alexandria, which is 800 kilometers due north of Syene, a meter stick cast a shadow of length 0.122 meters. Now, using only this information, he was able to figure out the circumference of the Earth. So long before we had the technology to explore our planet, he was able to use high school geometry to figure out how big our world was, to solve this enormously important problem. So, I want you to talk to a couple people sitting near you, see if you remember your high school geometry concepts, and we can kind of set up this problem.